Hello everybody, let's take a few moments and talk about something called the Intermediate Value Theorem. First, let me read the theorem to you. It says the Intermediate Value Theorem states that if f is continuous on a closed interval from a to b, where f of a does not equal f of b, and k is any number between f of a and f of b, then there's got to be at least one number c on the interval from a to b such that f of c is equal to k. When students read this at first, it often seems a confusing mess. What are they possibly trying to tell us here? Well, the intermediate value theorem, the IVT, is a function that really describes for us what a consequence of continuity of a function. First of all, we would want to ensure ourselves that we have a function that is continuous on some given closed interval. So let's consider this function f of x equals the square root of x plus 1 over the interval from 0 to 8. For the function to be continuous on the entire interval, there has to be at least one value c, such that for all values of c, that we know that f of c is defined, and we can certainly see that for every value of f of x that we substitute in, for every value of c that we substitute in, starting at 0 and ending at 8, there is always a y value out. There is no point at which the function becomes undefined over this interval. Also, that at every point c within this interval, that the limit as x approaches c of f of x exists. And as x approaches c for every point c over the entire interval, including at the endpoints, that our function's interval or limits exist. Now, there might be some argument about the endpoints of our interval, but we can actually look at the endpoints as one-sided limits instead and say, for example, if we wanted to evaluate the limit as x approached 8 from the left, well, as x approaches 8 from the left of the square root of x plus 1, we definitely get 3. And that limit exists and is equal to the value of f of 8. And so this function is definitely continuous at that endpoint. And of course, we'd assure ourselves that the limit for every point in this interval as x approaches c of f of x does equal the value of f of c. Well, that's true for every point within the interval, even at the endpoints. That's true. All right, so this is a continuous function on a closed interval from 0 to 8. Now, of course, we want to say in this interval, f of a does not equal f of b. Well, it is certainly the case that f of 0 equals 1, and f of 8 is equal to 3. And we can get that off the graph, although we didn't even really have to have the graph to show that, as long as we knew we had a continuous function. And it says, and k is any number between f of a and f of b. All right, so here's f of a on my graph. F of 0 is here. And here's f of b, right? So here's f of 8. So for any value of k in between f of 0 and f of 8, so k is some number in between 1 and 3. For any number between 1 and 3, this theorem concludes that there's got to be at least one number c on that interval, such that if we found the value at c, we would get k. This guarantees us that that's going to happen. So as an example, let's consider what k equals 2. All right? Well, if k equals 2, then we're saying by the conclusion of this theorem, there has to be some value of c that's equal to 2. So here's 2. Right? We want to assure ourselves that by setting the function equal to 2, we'll definitely get a value somewhere between 0 and 8. Will we? Of course we will. Because if we take the square root of c plus 1 and set that equal to 2, as guaranteed by the theorem, we should be able to find a value of c somewhere between 0 and 8. Well, let's square both sides to get rid of the square root. The square root of c plus 1 squared is just c plus 1, so we square the other side and we get 4. And then by subtracting 1 on both sides, we find c equals 3. Well, 3 is definitely on the interval from 0 to 8. And visually, right, we know that this is going to be 3 down here. So, yes, by the conclusion of the intermediate value theorem, there is definitely one value for which f of c is equal to 2, and that value is 3. So it just verifies that this intermediate value theorem is correct. By the way, the intermediate value theorem is useful because it gives us a way of definitely establishing the existence of a y value for every point of x on the interval between f of a and f of b. As long as it meets these conditions, that's perfect. That's what we want.